We'll go ahead and finish up section 1.6 here in this video. We're talking about inverse functions. And so just got two more examples left. The first one is f of x equals negative x squared plus 2. So I want us to find the inverse of f, the domain of f, and the range of f. Okay? Let's see. So I'll call this y. Y and f of x are the same thing, right? So y equals negative x squared plus 2. And finding the inverse, so it's all about switching x and y. So I got the equation x equals negative y squared plus 2. And I got to solve that for y. Okay, let me subtract 2 from both sides. And then multiply both sides by negative 1. So y squared is equal to 2 minus x. And then to get y all alone, I'm going to take the square root of both sides. I always need to tack on a plus and minus whenever I take the square root of both sides in an equation. So y is equal to plus or minus the square root of 2 minus x. Okay? So the first thing is f 1 to 1. This is my answer. This is the inverse, but no, f is not 1 to 1. The inverse is not a function. Okay? So because I know that for a function to happen, for each x there's only one y. There's not a plus y and a minus y. There's only one y. Okay? So I don't want to use the inverse function notation here. I don't want to say f inverse of x equals plus or minus the square root of 2 minus x. That would be wrong. Okay? F is not 1 to 1, so there is no inverse function. Okay, and I got to be careful on how I word this here because I'm not saying that there's no inverse. Every function has an inverse. We just computed it. All I'm saying is that the inverse is not a function. Okay, and that's another question there. So this is my answer. Okay, the inverse is not a function because for each x there's only one y, not a plus y and a minus y. Okay, let's state the domain and the range of f. Here's f. F is called a quadratic function. We're going to talk a lot about quadratic functions in the next chapter. The domain, again, there's only two things that I'm looking for with domain here. Number one, I can't divide by 0. Number two, I can't have a negative underneath the square root sign. I don't have any division going on, and I don't have any square roots. Okay, so all real numbers all the time for this function, right? Because this function is saying pick a number, can be any number, whatever number that is, square it, multiply by negative 1, and then add 2. And I'll just get another number in return. I can do that, though, to any number I want. Okay, so the domain would be all real numbers. The range is the domain of the inverse. Okay, and there's a couple of different ways that I can get the range here. The first thing is I can use transformations on y equals x squared. So I have a parabola, y equals x squared. The negative is in front of that, so I'm going to flip the parabola upside down, and then plus 2 means I'll shift it up 2 units. Okay, so I'm looking at a parabola here, it's facing downward. Okay, here's 0, 2 on the graph. That's the highest point. Okay, here's x and here's y. What is the range of that function? Well, range means I'm talking about the y values, right? So anywhere that's 2 or less is going to put me on the graph when I look to the left or the right. So I'll say the set of all y values such that y is less than or equal to 2. Okay? Remember that the range of a function is always the same set as the domain of the inverse. Well, here's the inverse. What is its domain? Okay? Domain means I'm talking about x. So the square root of 2 minus x, well, I know that I don't want 2 minus x to be a negative. So if I set 2 minus x to be greater than or equal to 0, so not a negative, and I solve that, it looks like anything that is less than or equal to 2 is going to be okay. Now, the only adjustment there would be to change x to y, because you're talking about the range of the function. But it's still going to be the same group of numbers. Anything that's less than or equal to 2 is the range. Okay? We'll try one more example here. So what if we have f of x equals 1 over x plus 2? Okay, and let's find the inverse of f in the domain and the range of f. Okay, well, y and f of x are the same thing, right? So y equals 1 over x plus 2, and I'm finding the inverse, so I need to switch x and y. So I need to solve the equation x equals 1 over y plus 2. I need to solve that for y. If we multiply both sides of this equation by y plus 2, x times y plus 2, that's the same thing as x times y plus 2 times x. That would be equal to 1 on the right. Okay, we're solving for y, so let's go ahead and subtract 2x from both sides, and then we'll divide by x. So y is equal to 1 minus 2x all over x. That's the inverse. Now the inverse is a function. How I know that is because I don't have any plus minus thing going on here for y, right? Like I did with this problem. So for each x, there's only one y, right? So if I wanted to, I can use the inverse function notation. That'd be fine for this problem. I could say f inverse of x equals 1 minus 2x all over x. Okay? And now how do I know that I got the right answer? Well, I can check that. So we saw earlier in the last video that to check and see if two functions are inverse of each other, you're going to plug each one into the other and check and see that you get plain old x. So I need to know, does f of f inverse of x end up being just x? And if it does, then I can check and see that f inverse of f of x also gives me just x. Okay, so let's check that. F of f inverse of x. Well, f inverse is 1 minus 2x over x. Here's f of x, 1 over x plus 2. So everywhere that I see an x and f, I need to replace that with 1 minus 2x all over x. Okay, so I'm looking at 1 divided by 1 minus 2x over x plus 2. Now the next question is, does this simplify to be just x? Well, 2 is the same as 2x over x. Right, so I got my common denominator down under of x. And if I get a single fraction out of that, I got 1 minus 2x plus 2x. Negative 2x plus 2x is 0. So I'm looking at 1 divided by 1 over x. And because I'm dividing by a fraction, I'll flip the denominator. And this is the same as x over 1, or just x. Okay, now at this point, I'm pretty sure that I got the right answer. It's hardly ever going to be the case that, one side gives you just x and the other side doesn't, okay? But to be totally sure, let's check also that f inverse of f of x gives us just x. Okay, so f inverse of f of x is 1 over x plus 2. Right, so everywhere that I see an x in the inverse function, there's two x's there, I need to replace that with 1 over x plus 2. And then, now the next question is, does this simplify to be just x? 1 is the same as x plus 2 over x plus 2. So I have my common denominator up top of x plus 2. And I got x plus 2 minus 2. And I'm dividing this by 1 over x plus 2. X plus 2 minus 2 is the same thing as x. X divided by x plus 2 divided by 1 over x plus 2 means that if I flip the denominator, the x plus 2's cancel. Right? Because I got x divided by x plus 2 times x plus 2 over 1. That's the same thing as x over 1, or just x. Okay, so because I'm getting just x on both of these, I can go ahead and circle my answer there. That's correct. I know I got the right answer. Now, what if we want to know the domain and the range of f? So here's f of x. I know I can't divide by 0, so x cannot be negative 2. Negative 2 plus 2 is 0, down under. So I don't want x to be negative 2. Okay, so I'll say the set of all x such that x is not equal to negative 2. That's the domain of f. And the range of f, so what's coming out of the function, the range of a function is the same thing as the domain of the inverse. So here's the inverse. We just computed it. What is its domain? Well, I know I can't divide by 0, right? So just don't let x be 0. Okay? And the only change would be to, instead of using x, call it y, right? Because you're talking about the range of the function, f. So it'd be the set of all y values such that y is not equal to 0. Okay? All right, so that's it for section 1.6. The homework is on page 100. Be sure to look at those problems. And then also, there's a couple of problems that I would like you to look at. It looks like 4 problems that are on page 264 in the book. So for whatever strange reason, they talk about inverse functions a little bit in this section, and then they talk about inverse functions again in section 3.8. So I don't know why they do that, but I would like you to look at problems 11 through 14. These 4 problems here are also on that page. Okay. And all right, so in the next video, I'll get into chapter 2 a bit.